Today we're going to continue talking about the quadratic formula, but more specifically the discriminant. I referenced the discriminant a couple times in our previous lesson, but now we're going to look specifically at that discriminant to make some predictions about the number and type of solutions that a quadratic formula might have. We're also going to look at quadratic inequalities. So let's start with the discriminant. In this first example, I'm going to start just like I would if I was setting up the problem for a quadratic formula. I need to make sure that everything is in standard form, meaning that I have everything on the same side and that it is in ax squared plus bx plus c order. So my 6p squared can stay where it is, but I need to move the 4p to the left side. It's going to become a negative 4p. And then I have negative 7. And I'll set this all equal to 0. Just like I did in the previous lesson, I'm going to identify my a, my b, and my c. A is 6, b is negative 4, and c is negative 7. Now, the discriminant is just the numbers underneath the square root. B squared minus 4ac. It's the part that I told you could put in your calculator. Don't forget to use parentheses, just like we did yesterday. So now I'll set the problem up. I've got b squared, so I'll put my negative 4 right there, minus 4 times a, which is 6, and c, which is negative 7. Now you can put this in your calculator. Remember to put it in exactly as you see it here. Also remember that there is a difference between your negative signs and your minus signs. Once you put this in your calculator, you're going to get 184. So what does that tell me about the number and the type of solutions? Well, if you think about the fact that this is the number that goes underneath the radical in your quadratic formula, this is not a perfect square. And since it's not a perfect square, it's not going to come completely out of the radical, which means a radical will remain in my answer. So, if you think back to the previous lesson, when the radical remains in the answer, there are two solutions because you do have that plus or minus sign, and those solutions have radicals in them, which make those solutions irrational. So this is the number of solutions, and this is the type of solution. All right, let's look at another kind. Number 2, we're going to start by moving everything to the same side. So I have 7a squared minus 9a, and you may have noticed that the c is missing. So yesterday we talked about that if you have a part of your quadratic formula missing, like the b or the c, you're just going to put a 0. So my a term is 7, my b is negative 9, and my c is 0. Now let's set up our problem. B squared minus 4 times a times c. Well, anytime 0 shows up, it usually makes your problem a little bit easier. 0 times 7 times negative 4 is just 0. So that part of my problem goes away. Negative 9 squared gives me an 81. Now again, think about this. This is the number underneath your square root. This time, it's a perfect square. So if you have a perfect square, it means that the radical goes away and the answer comes out. In a case like this, you still have two solutions. But this time, your solutions are rational because the radical does not remain. Rational answers could be whole numbers, and they could be fractions. Number 3, this is our third type. Again, we need to start off by rearranging our terms. So we're going to bring the negative 8x over here as positive 8x, and the negative 8 will become positive 8, and we'll set it all equal to 0. We're going to identify our a term as 2, b 8, and c is also 8. And then I'll set up my discriminant. B squared minus 4 times A times C. You can put this in your calculator, and this time your answer is going to be 0. All right, so if you have 0 under the square root in the quadratic formula, what's happening? Well, the radical definitely goes away. In fact, that whole part of the problem goes away, including the plus or minus, because plus or minus 0 really doesn't mean anything. Well, if the plus or minus go away in your quadratic formula, now you only have one solution. This is the only time that you're going to have one solution. And since the radical went away, this solution is going to be rational. All right, the fourth and final type of problem is going to begin the same way. We got to get everything on the same side. 10k squared. We're going to bring this negative 3k over to the left as a positive 3k, and then write down my positive 8 equal to 0. My A is 10, my B is 3, and my C is 8. Now I'll set up my discriminant. B squared minus 4 times A times C. And that gives me negative 311. So what does a negative tell me? This is different than any of the previous ones. I know that 311 isn't a perfect square, so this number is going to remain under my radical. But the negative is actually the most important part of this answer. If you have a negative that is underneath a radical, you are going to get imaginary answers. And you're going to get 2 of them. So you will have 2 solutions, and they will be imaginary. They are going to have an I in them. Now, another way that you'll see imaginary written in multiple choice questions, and I want you to be aware of this, is they may use the words non-real. So if you see that, that's all they mean, imaginary. All right, number 5 begins our quadratic inequalities. I'm actually going to reduce the size of this a little just so I have plenty of room. In a quadratic inequality, we're going to start the problem the same way that we have all the rest of them. We need to get everything on the same side, and we're going to look for a method for solving these. Now, I'm going to go ahead and tell you. I'm going to show you 4 examples, and all 4 of these examples can be factored. The ones in your homework can be factored also. The first thing I'll do is I will subtract x squared and bring it over here to the left so I can combine it with the other x squared term. That gives me x squared plus 2x minus 8 is greater than 0. Now for right now, I'm not really going to focus on this greater than. I want to focus on factoring this and solving this part, and then I'll come back to the inequality. When I factor this, I'm looking for 2 numbers that multiply to negative 8 that will subtract and give me 2. I know they subtract because they have opposite signs. What multiplies to 8 and subtracts to give me 2? 4 and 2. Now, like I said before, I want to know what the solutions to these are. The solution to this first is negative 4. The solution to the second is positive 2. How did I get those? I set each part equal to 0, and I solved for x. You also can just change the sign if they're simple like this. So how am I going to use this? In an inequality, we have sections of numbers that are true and sections of numbers that are false. And a number line is a good way to find out which ones are true and which ones are false. We use those solutions, negative 4 and positive 2, and we put them on the number line. Now we're going to focus on this inequality. This is a greater than sign. It doesn't have an equal to underneath it. So I do have to decide what kind of circles I'm going to put at these two numbers. If it is not equal to, then we leave it an open circle. And if you see that equal to line, you would color it in. So both of these will be open. Now to solve this, I have to test a number in each section of this number line. I need to pick something smaller than -4. I'm just going to pick -5. I pick something in between -4 and 2. 0 is good. It's an easy number to plug in. And something bigger than 2, 3. I'm going to plug these numbers, these three numbers, into these two x's and see what I get. If I put -5 plus 4, I get -1. And -5 minus 2 is -7. I just need to know, is +7 greater than 0? Yes, that's a true statement. If it's true, I'm going to shade that portion of the number line. Now I got to test out the middle. If I do 0 plus 4, I get 4. 0 minus 2 is -2. When I multiply those, I get -8. Is -8 bigger than 0? No, that's false. So what about 3? 3 plus 4 is 7. 3 minus 2 is 1. Is 7 greater than 0? Yes, that's true. So now we have our number line, but we're not done. We've got to express our answer using interval notation. So here's how interval notation works. You're going to have to use infinity, especially if you are shading the outer parts of your number line. A number line goes on forever and ever and ever, and this is the negative side of the number line, so this side is headed to -infinity. This is the positive side of the number line, so this side is headed to positive infinity. So here's how it works. You need to look at the ends of your shading, because the ends of your shading will be the numbers you use to write your intervals. So on this side, this interval goes from -infinity to -4. Those are my two ends. You put a comma in between those ends. And you're going to choose either a parentheses or a bracket. So here's how parentheses and brackets work. It's the same as closed and open circles. A closed circle will be a bracket. An open circle will be a parentheses. Infinities always have parentheses because they continue on and on. When you see a bracket, it's almost like a stop sign. The line stops here, but a parentheses allows you to continue. This circle is open, so it's a parentheses. So this is one of my intervals. I'm going to write the word and because I'm also including this interval. It goes from 2 to positive infinity. 2 is an open circle, so it's a parentheses. Infinity always is a parentheses. So these are my two intervals, and I write the word and to show that both of them are true at the same time. Number 6. Same type of problem. I'm going to start by getting everything on the same side. The main difference that you're going to notice with this problem is that I have a lead coefficient and I can't divide it out. So you've got a couple options. You can either split the middle or you can take your first term and multiply it times your last term. And that's the way I'm going to go. So I'll take 3, multiply it times -10, and that gives me a -30. I need two numbers that multiply to -30 that can subtract and give me 13. Remember, I know they subtract because they got opposite signs. All right, it's 15 and 2. 15 is my positive, 2 is my negative. Now don't forget, because you had this lead term, you have to divide each of them by 3. That gives me x plus 5 and 3x minus 2. So there's my factors. What numbers are going to go on the number line? Remember, make it easy on yourself. You're going to do the opposite of this number. So negative 5 will be on my number line. What else is going to be on my number line? I can set this equal to 0 and solve, or I can just kind of jump back up a step. Just change the sign here. Positive 2/3. So we're going to put negative 5 and positive 2/3. So what kind of circle are both of these going to have? This has an equal to, so they're both going to be solid circles. I need to choose a number from each of these sections. Something smaller than negative 5, we'll just choose negative 6. Something in between negative 5 and 2/3, 0. And something bigger than 2/3, 1. Just choose any number. Just make it easier on yourself. Now we'll plug them in. If I put negative 6 plus 5, I get negative 1. If I plug negative 6 in here and solve this equation, I'm going to get negative 20. When I multiply these together, is positive 20 greater than or equal to 0? Yes, it's true. So I will shade that section. Now let's test the 0. 0 plus 5 is 5. When I plug 0 in here, I get negative 2. Is negative 10 greater than 0? Nope. Let's try 1. 1 plus 5 is 6. When I put 1 here, I get 1. Is 6 greater than or equal to 0? Yes. So now I have my shading done, and it's time to write my inequality. Remember that this side is negative infinity, and this side is positive infinity. And the numbers that I'm going to use are the ends. So these are my numbers right here. This interval will go from negative infinity to negative 5. Infinity always gets a parentheses. Now I'm going to look up here at the negative 5. This time it's a solid circle. Solid circles get brackets. They're like stop signs. On this one, I have 2/3 and I have infinity. Infinity always gets the parentheses. This is solid, it gets a bracket. We'll write the word and in between because both are true at the same time. All right, in this example, we need to start off by adding 8 to both sides. When we do that, it actually cancels out the 8 in both sides, leaving only 2x squared plus 10x less than or equal to 0. I still want to factor. Since I don't have 3 terms, I need to definitely ask myself, do these 2 terms have something in common? And they do. They're both divided by 2x. When I do that, I'm left with x plus 5. When I solve this, both parts are going to get set equal to 0. So the solution to this first part, 2x equals 0, is just 0. When I set x plus 5 equal to 0, I get negative 5. So these will be the 2 points on my number line. Make sure you put them in the correct order. Negative 5 is smaller than 0. Now that you have your points, now you're going to look at your inequality. Will you put a solid circle or a hollow circle? Solid. And now it's time to choose 3 points so that we can test. Something smaller would be negative 6. Something in the middle, I don't know, negative 1 or negative 2. Why not negative 2? And then something bigger, let's just choose 1. So when we plug these numbers in, 2 times negative 6 is negative 12, and negative 6 plus 5 is negative 1. When I multiply that, I get positive 12 is less than 0. That's not true. Let's try negative 2. If I do 2 times negative 2, I get negative 4. And negative 2 plus 5 is 3. When I multiply those, I get negative 12 is less than 0. That's true. So I'm shading in the middle. If I test the 1, 2 times 1 is 1. 1 plus 5 is 6. 6 is not less than 0. That is false. So my only section is this center section. This time I will not have 2 intervals. I will only have 1. And these are the numbers that I'm going to use for this interval. Negative 5, comma, 0. So what will I put on them? Parentheses or brackets? Since both of them have a solid circle, both of them will get brackets. All right, let's look at this last example. Again, we need to get everything on the same side. We're going to start by subtracting 3x. When we do that, it does cancel out our x on both sides, leaving x squared minus 81 less than 0. Hopefully, when you look at this, you immediately notice that this is the difference of 2 squares. X plus 9, x minus 9. When I solve them, I'm going to get a negative 9 and a positive 9. So I'll go ahead and write out my number line and put negative 9 and positive 9. What kind of circles are these going to have? They're both open. I need to choose a number in all 3 sections. So negative 10, 0, 10. Now let's plug in and see what's true and what's false. If I put negative 10, that gives me a negative 1 here and a negative 19. When I multiply those together, I have positive 19 is less than 0. That's a false statement. When I put 0 in, I'm going to get 9 times negative 9. That's negative 81 is less than 0. That's true. And then this last section, 10 plus 9 is 19. 10 minus 9 is 1. And we know already 19 is not less than 0. That's false. So now it's time to write my interval. I'm going to use the ends of the interval that is shaded. This is only going to have one interval since it's only the center section. It will start at negative 9 and it goes to positive 9. What kind of brackets or parentheses will I put on this interval? Since both ends are open, both will be parentheses.